What's up, Algebra 2? Just doing a video to talk a little bit more about some of the questions that we were talking about today. If you were given for homework, they all live around the idea of exponential growth and decay. Could be continuously, that's for PERT. Could be compounded monthly, daily, weekly. That's when we use our n in our formula. And then we also have some log properties that go with these, and so we're going to continue to talk about that. Here we go. So an initial population of 230 animals. It's our initial value. If you're thinking about like a times b to the x, that's our a. And if you're thinking about it in terms of just basic, simple interest, it's not compounded more than once a year, then we'd be using this formula where you use n as 1 essentially. Okay? And in that case, it's p. And I know that can be complicated using multiple formulas, but they all really mean and do the same thing. It's just, you know, which questions you use them for. So for this one, we're going to say that this is our R value. Now we need to say that that's really 0.19. We want to use that as a decimal, of course. And then our time is in 5 years. So let's start with 230. This word is super important because this plus could be a minus. It just depends on if you're going up for growth or if you're going down for decay. So this one's decreasing, so we'll say 1 minus 0.19, and then we'll raise it to the time of 5 years. Okay? So to clean that up just a little bit, 100% minus 19%, you're retaining 81% of the original 230 every year. So it's going down, but you are getting 4/5 of it almost. Okay? 81%, it's close to 4 out of 5. But you are getting less every single time. So I'm going to put this in the calculator. 230, parentheses, you could do 1 minus 0.19 raised to the 5th, but that would be the same as just doing 0.81. So we're looking at around 80, maybe 80.2, okay? But because we're talking about like initial population in 5 years, I may just say 80 animals, okay? And this is used all the time in science because they're tagging animals in the wild, they're looking for them later, they're figuring out if that's increasing or decreasing so they can determine if the population for bears or for deer is on the rise or if it's going down. And so obviously that sounds like it's something important, especially if you're in conservation. All right, evaluate log base 4 of 7. So I've been showing that here using what we call change of base. So log of 7 divide log of 4. Okay, so we always want to make sure that this works because sometimes you may get it flipped. So I'll just say, okay, let's just check. Is 4 to this value, 1.14, all that previous answer, is that exactly 7? Sure is. So 1.40. Okay, about. I did approximate that. So again, make sure that you notice that 7 is kind of above 4. Maybe not as clear in this particular example, but you always want to put the base, 4 is the base here, put the base in the bottom. Okay, and that will make it a lot easier. So I want to talk about expanding next. Remember, expanding means we want to make multiple logs based on whether they were multiplying. If they were multiplying, that means you want to use an adding symbol. And if they're dividing, you want to make sure that you use a minus symbol. Okay? So let's talk about A first. A is kind of the hardest one, I believe. And so the reason why I think it's the hardest is because some people could really get caught up with the top part. But there's no way to separate a plus that's inside of it. We can only really separate things that are being divided. And so even though these two are being multiplied and these two are being multiplied, ultimately they're being added. So I really can't break that particular thing up. So if this means division, to expand this, I'm going to need to have a subtraction symbol between both logs. Okay? So the first one is x squared plus 3x, and the second one is x to the 5th. So again, this one does have a power of 2, but it's also adding with 3x. It's just not really a great way to kind of break that up. So what I could do is I could just think about this 5, because that one's a little easier. I could take that 5 and put it here. Okay, and that's called that swing rule, I call it, where basically you can put a power out front as a coefficient. Now, to be honest, there probably is something that I could do here, because this is what we call factorable. Okay, one way that I could write that is x times x plus 3. So again, see what I've changed it to is a form of multiplication. So if I wanted to separate those, I could. That would be log base 4 of x. And because that multiplication is there, I could say, okay, now log base 4 of x plus 3. So that's a little more advanced. I don't know if I would count off too much if you didn't quite see that. But to be honest, that is something you can do. Okay, because you can multiply these back together, and that'd be x times x plus 3, or x squared plus 3x, and then you can put the other one back if you wanted to condense it. Condense is when you go from this long version going back to the original where it's all in one log. Okay, so the next one, we have the square root. And so one thing that I want to remind you is that the square root is like the 1/2 power. Okay, so this right here can really be rewritten like x to the 1/2 divided by y to the 1/2. Okay, because you're square rooting both essentially. So I just want to keep that in mind as we're doing this. So I have log base 5 of 5. And I want that to be a positive out front because it's currently multiplying. So it's going to be multiplying against this log of x to the 1/2. And then you're subtracting, because technically you're dividing by this other log of y to the 1/2. Okay? Now there's two things that happen, and they're really kind of the same idea. These powers of 1/2 could swing to be out front. So I could put them here. And that way, that is fully expanded, and I can do more with it during like the solving process if need be. Okay? So let's talk about C for a moment. If you need to pause the video or go back to part B to get that answer, please do so. But right now, I am going to erase it so that I can have room. Okay. This is log of 3. It's multiplying against log of x to the negative 1, which is multiplying against log of y to the 3rd. So I need 3 logs. And I'm going to separate them with a plus every time I see multiplication. And since they're all against each other, they're all multiplying. Okay? So just like on the last one, all the powers could technically swing out front. Sorry, trying to be slick. So instead of that negative 1, it could be here. And instead of that 3, it could be here. Okay? So I'm swinging them out front. So one thing that does change right here is that adding negative 1 log is the same as subtraction. Now, I know you're thinking possibly like, why is that? I thought these were multiplying. Well, they are multiplying, but this value in particular is 1 over x. Negative 1 powers really mean how many times that number has divided. So technically, that number is dividing, and so that's why it's okay for us to see that minus there. And then, of course, the other one I just need to finish writing. Okay? So those are some examples of expanding, and we'll look at one problem where you are condensing. So we're trying to condense, which means to put all those back together into one log using those same power rules. Okay? So this right here can swing. That's really 1/5. This right here can swing, and that's really x squared. And then this thing can swing, and that gives you 1/2. Okay? So basically, I've kind of moved all of those numbers to be in a different place within each log. So what I have is log base 3. And just like the 1/2 power is the square root, the 1/5 power is the 5th root. So technically, that number is the 5th root of 32. Now that number is secretly 2, okay? But maybe for now we'll just leave that here. We'll come back to it, okay? Minus means we're dividing. So that means all of that is being divided by x squared. And because this was a plus, that means it's multiplying. So if I have to choose somewhere for it to be, it should probably be in the top, okay? So I'm going to put a square root of y here, and that's it, okay? So I have put them all together, but just like I said, the fifth root of 32, that number is really an integer. That's really 2. 2 to the fifth is 32. And so this could be the cleanest way you could write the final answer. So hopefully you can kind of look at some of the other problems, especially some of these where we're solving, okay? So I'm looking at these and I'm really thinking, man, we're going to need some practice with those. So please come in with some questions. If you have some time to look at those and try to explore those, you're going to be better off than having not looked at them at all until tomorrow. Sorry, I got the hiccups. So I think that's it for today's video. Please email me if you have any questions.